Electric forces, Coulombs law. So the forces between two charges is proportional to, inversely proportional to the distance between two charges. The square of the distance between two charges is F proportional to 1 over r power 2. R is distance between two charges object. Also, the force is proportional to the amount of the charge on the first object and amount of charge on the second object. If you want to just write the equation, the force between two charges, it would be F equal to K. K is a constant. Q1 is the charge on the first object. Q2 is the charge on the second object divided by r power 2, the square of the distance between two charges. So this is Coulombs law. Let's say Q1 and Q2 is one of them is positive, one of them is negative. Of course, they will be attracted to each other. So when they move towards each other, it means the direction of the force is going to be toward each other. So this will come to the right, the A go to the right and B go to the left. It means the direction of the force for the B is to the left and direction of the force for A is to the right. Knowing that the force is vector, if we have multiple charges, we need to add them and treat them as a vector. A K constant is 10⁻⁹ Newton meter squared divided by Coulomb. So if you take the above equation, the Coulombs law, this one that I did talk about, where is it? This one, and you rearrange it for K, you'll get this, right? The F is Newton, r power 2, r is a distance in meter square, and charges, the unit for the charges is Coulomb. So Coulomb to the power of 2 in denominator. So this is how we come up with the units. Looking at this question, the magnitude of the electrostatic force between two small, essentially point-like charged objects is 5⁻⁻5 Newton. Calculate the force for each of the following situations. The distance between the charges is doubled while the size of the charge stays the same. So you know the equation, right? So F is equal to K, Q1, Q2 divided by r power 2. So if the distance between the charges is that means r become twice, right? So if this one is twice, since the denominator is going to be 1/4, of course. So your force become 1/4. So just divide this one by 4 and you will get your answer. The charges on object is tripled. On one object is tripled, while the charge on other is halved. So this, it becomes tripled, and this become halved. So the overall force becomes 3/2, right? So if you multiply this force by 3/2, you'll get your answer. So just going here, multiply this one by 3/2, you'll get your answer. Also, both charges are both changes, this changes and this changes happen same time. It means it's 3/2 times multiplied by 1/4, which is 3/8, right? So if you multiply this number by 3/8, you'll get the answer. As you see here, all of the changes happen at the same time. Okay, let me erase this. So the second problem is, what is the magnitude of the force of the repulsion between two small spheres 1 meter apart? Each has a charge of 1⁻⁻12 Coulomb. So we have Q1 and Q2, we have distance r, we want to find F. Let's just simply put that in equation. K constant, you know, is 9⁻⁹. Q1 is given, Q2 is given, r is given, you just simply calculate the force. For practice, do question number 1 here. Question number 1, 2, 3, 4, 5, 6, and 7 are good practice question for you to do. So Coulombs law versus the law of the universal gravitational. So let's just look at these two equations, very similar, right? You have a constant K here, If you have electric force between two charges, Q1 and Q2, here is the gravitational force between two masses, mass 1 and mass 2. Very similar. So they both have constant G here, cosine K. It is involved masses 1 and mass 2, and here is charge 1, charge 2, and it is divided by a square distance between two objects, the same way here. But knowing that the electric force could be attraction and repulsion, but gravitational force is just attraction. You can read through this if you want. Here is another example. You have three charges here. Charges here A and B are fixed and have a charges of positive on A, and here is the negative. Calculate the net force on a sphere C, which it is positive charge here, right? So I know positive, the A apply force on C, but in what direction? A is positive, C is positive, repel. So this would like go away from A. That's why this is force A on C is in this direction. And this one, B is negative, C is positive. So this one would like to be attracted to that. So the force that B exerted on C is going to be in this direction, F of BC. Then we simply calculate the F of AC, F of BC. Then, you know, they are in opposite direction. We know we need to subtract them. So of AC or CA is KQA, QC divided by the distance between them. Distance between them is 30. The Q1 and QA and QC is given. You just simply calculate that as 2.6 Newton. The same way you can calculate F of CB. Put the charges, constants is 1.4. So 2.6 is to the right, and here's to the left. And you added, this is positive and this is negative, right? Use 2.6 minus 1.4. It is 1.2, which is to the right because the F of AC is bigger. Okay, next question. That. So here is identical as sphere ABCDs. Each charge is positive 5, 10. Our negative 6 Coulomb is situated in a corner of a square whose side is 25 centimeter. We need to convert that to the meter. Two diagonal opposite charges are opposite, are positive. So, and the two negative, okay, so these two are positive and these two are negative, as shown. Calculate the net force acting on each of four sphere. Okay, I will show you one of that calculation. See what they did. They did it for A. Okay, A experienced 3 forces, one from B, one from D, and one from C. See the direction of these forces. C and A both are positive, so C will repel A. So it's going to be F, A, C. In this direction is positive, negative, so it will go toward that, so it will be attracted. So it's going to be F, A, B. Here is positive, here is negative, so it will be attracted. So it's going to be F, A, D. Okay. Then I just need to find the magnitude of each forces and add them like a vector. Make sure you consider them as X and Y component, add X components separately and add Y components separately and put them together using the Pythagorean theorem. You know that this is the square, so you know this is 45. If you have the magnitude of FAC, you can find the X and Y component. Here is for F of AB, it is X component. F of AD is just Y component, right? So you find total f of x component, find total f of y component. Then when you find that, you put them together using the Pythagorean theorem. F of y power 2. It's going to be force total. And the angle will be tan inverse of total y component divided by total x component. This is what we have done before when you add in the vectors. I hope you remember those. See, they did it. They find the forces diagonally is 1.8. This is AC, right? Then here they find x and y component. They added all of the x component here. Make sure the x component of the f of AC is negative. That's why we find the x component of x. We put it negative. Also, the y component of f of AD is negative because it's downward, right? Make sure of that. So put them together using the Pythagorean theorem. Find the angle, force, the total force in y direction divided by force in x direction, tan inverse of that give you the angle. So to do a practice question number 8 and 9, you can try to do those questions for your practice.